In the previous video, we saw the formula of the Black-Scholes model. So in this case study, let us see how we have to calculate the BSM model. This is the example sum for the BSM model which is given in the previous year case study. So the current price of stock is rupees 90% per share. The risk-free interest rate is 8% annualized continuous compounding if the volatility of stock is 23% per annum. The volatility of stock is considered as the standard deviation. What is the price of 80 rupees call option expiring in 6 months? So here they mention us to calculate the call option method. So we have to calculate the call option. So there is no need to calculate the put option. How we have to write in the case study. In the Black-Scholes model, this is the title we are giving, and to calculate what we have to calculate here, call option. Black-Scholes model, call option. The step 1, whatever they mention in the sum, we have to mention in the step 1. In the step 1, given in the case, the stock price is 90, the exercise price K, we have to calculate it. So in the sum, they didn't mention, but there is a formula to calculate the exercise price K. Okay, expected price or exercise price. The risk-free rate of interest is equal to 8%. So this 8% can be converted into the decimal point. The decimal points is equal to 0.08 for the 8%. So the standard deviation is equal to 23%. This standard deviation 23% is converted into decimal points. This is 0.23. Time is equal to 6 months. We know that for the year there will be the 12 months. So now we have to do the division. 6 by 12. 6 months divided by 12 months is equal to 0.5. So the time period is equal to 0.5. Now how we have to calculate the value of the K? Exercise price K for call option K is equal to S into 1 plus R%. Where coming to the put option K is equal to S into 1 minus R%. So K is equal to, we know the value of the stock 90. 1 plus 0.08. So we have to find out the call option. So here we are calculating the call option value for the exercise price. 90 into 1 plus 0.08. 1 plus 0.08 is equal to 1.08. So 90 into 1.08 is equal to 97.2. Okay, this is the first step in the case study. We have to write whatever given in the sum in the step 1. Okay, next step 2. In the step 2, we have to write the formula. So to calculate the call option, the formula, the distribution D1, the deviations, integer nominal distribution. So A or log, we can see the natural logs. Okay, ln into S by K. S by K means stock by exercise rate plus R plus 1 by 2 into standard deviation square into time divided by standard deviation into square root of time. So this is the formula for the D1, and coming to the D2, the formula is very simple, which is D1 minus standard deviation square root of T. So when we are going to calculate the call option, the formula is equal to C is equal to stock into nominal distribution D1 minus K to the power of minus E or T into nominal distribution D2. So when we are coming to the put option, P is equal to K into E to the power of E. When we are coming to the put option, P is equal to K to the power of E minus RT into 1 minus nominal distribution D2 minus stock into 1 minus nominal distribution D1. So in this formula, by using this formula, we can calculate the Black-Scholes model. Without this formula, we cannot calculate. So must and should we have to remember this formula to calculate the Black-Scholes models. It is very simple if you do the practice. Now here I mentioned to understood that what is the ND1 or ND2. So ND1 or ND2 is called standard nominal distribution evaluated at D1 or D2. Okay. And one more thing I want to mention here about the E. The E is the standard value. E is equal to the standard value we can calculate the E value is the permanent value, and you have to remember that E value is very important to calculate in the sum. E is equal to square root of 2.7183. You have to you have to remember this value. E is equal to square root of 2.7183. This is the constant value. There is no change for this value. When we are going to calculate this D1 or D2 values, this value is very important to calculate us. Okay. Now let us go to the step 3.